The first part of the presentation consists of some slides. We'll kind of describe the problem space a little bit, describe exactly where you might use a JBoss ESB or any kind of enterprise service bus solution, some of the interesting capabilities of our solution, and then we're going to focus on a little demonstration to show you some of the advanced concepts that are available to you on JBoss ESB. And do note that all this is open source and available on jboss.org for download at this moment. So I'm not showing you anything in here that's proprietary. Everything is available to you. In some cases, I downloaded it just last week to build the little demonstrations so we could show it here for you today. Okay, so we're going to focus on JBoss ESB 4.5, and that'll be our focus for this particular session. One of the things I like to do is kind of position where an ESB fits versus an application server. Most people understand what to do in an application server these days. You know, the market is matured enough for people to go, okay, I know what an app server does. I can build my web applications on top of it. I can actually host things like servlets, JSPs. I might even have a web service on it, an EJB, maybe some JCA components or JMS components. Most people understand what to do with that technology now, and people are pretty comfortable with the nature of it. You can also extend an application server with some advanced capability. Like I might want to add a rules engine to it, like Drools from jboss.org, or JBPM, a BPM solution that can be extended into the back of your web-based applications, as an example. In this particular case, when it comes to app server clustering, everything looks the same. So that, most people understand this concept, right? I have an app server, I have a single WAR or ear sitting on the application server, and then I have 4 application servers where everything is replicated. Should any one of them go away, the other 3 pick up the load and everything's okay. So again, that's an application server kind of feature. In the case of a typical enterprise, however, I might have multiple systems and multiple clusters. I might have a CRM system, a billing system, an inventory system. Some of these I may have purchased, some of them I may have built, some of them I may have acquired when we merged in another organization. And if we want to integrate any of those different disparate systems, some form of registry and messaging typically takes place. When I say registry, I mean somebody knows what the other endpoint is. It doesn't have to be a real serious software-based registry. It might be an email that goes around the company and says, System 1 exists at this URL, System 2 is at this IP address, and System 3 is over here at this other place. It might be something as simple as that. When I say messaging, I don't necessarily mean JMS in this case. It might be FTP. FTP is still the king of system-to-system integration, especially across business partners. So I will transfer files back and forth to actually get my orders from System 1 to System 2 in many cases. I might, if I'm pretty clever, introduce the concept of routing or orchestration. So in other words, as let's say a new order flows into my enterprise, I might have to get it routed to 2 or 3 systems that have to be used in the provisioning process. So let's say I'm a telecom business and I receive an order for someone who needs voicemail and they need iPhones set up, right, with data services, and they need certain types of applications provisioned. They might actually have to hit 2 or 3 different internal systems. So some form of registration, or excuse me, orchestration has to occur. And that might again be a manual process, where I have a person who knows that if I receive an order that looks this way, I got to take it to A, then B, then C, skip D, and go to E, depending on what those business rules are. It gets more complicated though in a typical enterprise where I have multiple disparate systems. So in other words, it's not all Java, and I know we're here at Java 1 and most people think, hey, everything's 100% Java out there in the real world, but we recognize that there's something out there called .NET, there's something out there called Linux, Apache, MySQL, PHP, right, the LAMP stack. There's also legacy technologies that's out there, and there's a dozen other solutions that have been built and deployed in modern enterprises today. So it's not very common to find a whole Java environment. Typically you find multiple environments that are out there. So again, you still need messaging, some form of routing and orchestration. You might also need transport mediation. So now if I'm integrating between the .NET world and the Java world, I can't just make an RMI call. I have to use something like a web service or a RESTful call. And if I'm actually integrating between 2 different Java systems, I can't even use JMS in many cases, because JMS isn't interoperable on the wire level. So there's all these little tricks to doing transport mediation to basically make 2 systems interact with each other. If I'm integrating with a legacy system, I might have to use FTP, right, to get up to the mainframe, and I need to send it not XML, but ASCII or EBCDIC in many cases. So while we might think everything looks like XML in the real world, we recognize that there's a lot of systems out there that still look at older file types and older structures for their data. So you need some form of transformation, routing, orchestration, transport mediation. I might have to go beyond the firewall to talk to business partners, right? So typically we normally think inside the firewall, but what happens if I go outside my firewall? How do I deliver content? How do I deliver transactions? How do I integrate people out there in the world? And this is where your ESB sits. Right? So your enterprise service bus is a series of tools that give you some of these additional capabilities that go well beyond an application server. Okay? So at a very high level, that covers what an ESB is versus an application server, and I use that to kind of set a level ground for people who typically have an app server background. Now, one of the things I want to talk to you about here is this concept of orchestration, and the idea that you should understand what the business process looks like for your organization. So one of the things I encourage developers all the time to think about, because most people, if you're a developer, think about the specific widget that you're working on. Like I'll think about my specific credit check service that I have to create. You need to understand that it actually operates in a larger business process. That may not be an automated business process, it may be a manual business process, but there's still some end-to-end flow of events that have to occur throughout the IT department, throughout the enterprise, across multiple departments. So if you look here, it's a simple workflow. I receive the order, I validate the order, I might then do a credit check and an inventory check. If it comes back bad credit, no inventory, send it to the customer service response team, who has to call the customer and say, hey, we have an issue with your order, or maybe we don't even sell that product. If all goes well, we send out the shipment notice, and get the warehouses doing their job, right? Get it on the trucks, that kind of thing. If you look here below that line, though, you can see it says validate order, has to parse XML and do transformation, because we have multiple different business partners who send us orders in very different formats. So I have to get it to a canonical model, a common model within my organization. If you look here at credit check, this is an example of an asynchronous process that has to occur over a period of time. In this specific case, I might have 3 or 4 credit check business partners, different banks, let's say. And one of them will respond in 2 seconds, one of them will respond in 2 minutes, and the other one may respond in 2 days. So I may have to wait all that amount of time, 48 hours, before I continue on with this process. So the process has to be long running, it has to be persistent and stateful, and it has to remember where it is as far as the specific step and the specific state. And what's important about that is you can have business rules determine what to do with that state and the status of that business process. So for instance, in this case, let's say the guy comes back in 2 minutes, and in the 2-minute response, we have a great credit score. And in the 2-second response, we also have a great credit score. The 2-day response, we don't care anymore. If we get 2 out of 3 good responses, maybe we just move on with our business process and we let the customer order go through. Or maybe we apply more advanced business rules to say, well, it's a marginal credit score, let's wait a little bit longer, see what's going on, and then and then apply some math to it. If it's a 500 and 500 is a bare minimum, maybe we need to wait a little bit longer for that third party to respond in this case. So you can actually perform a lot of complexity in these asynchronous processes like this. Okay, we'll keep moving on. So what we've done with our ESB, and if you download the JBoss ESB from jboss.org, you actually will find there's this synergistic blend of the way we've taken JBPM, the Drools engine, the ESB technology, all of which based on the JMX microkernel architecture from the application server, so you have hot deployment of your services, things of that nature. All those things work together now in a seamless way to actually let you build these kinds of applications, these more complex applications that go well beyond simple point-to-point services or simple point-to-point servlets or EJB invocations. So you can see here in this case, my business process, which might be driven by a customer portal, okay, it might be driven by a customer portal. Specifically, if it's a portal-based system, it's obviously human interactive, user interactive. Right? There's a single human hitting a button on a screen, and that's specifically how they make the application start up. In this case, I might have a business-to-business partnership with SOAP services or FTP, and I want the exact same business logic, the exact same business services, and the exact same business rules, the same process, to execute irregardless. A human did it, a batch process did it, a user in a business partnership sent me a batch file of 4,000 orders. I want all the same process to occur, the same rules. So that's what's happened here within our ESB environment.